I'm Anil Kumar, and here is an interesting application on periodic sinusoidal function. The question here is, the spring bounces up and down according to the model d of t equals to 0.5 cos of 120t in degrees, where d of t is the displacement in centimeters from the rest position and t is time in seconds. What is the relationship between the amplitude of the function and the displacement from the rest position? Now let's try to sketch and understand the situation. So what we have here is kind of like this. Let us assume that we have a spring attached which is bouncing up and down according to a model. Okay, now so what we will do here is we can start from the ground also. So what we will do is we'll make it other way. So we'll start from here since the function is cosine. So let's say this is kind of the ground and we have a spring here, right? So we have the spring here. Okay, so the spring bounces up and down according to this model. So let's attach something here so that we have some reference. Okay. Now that's the position of the spring, and the question here is that the spring bounces up and down according to the model d of t equals to 0.5 cos of 120t, where d of t is displacement in centimeters from the rest position and t is the time in seconds. So now let us assume this to be the rest position. Okay, now what we are going to do here is that we are going to pull this spring a bit, right? In that case, what really happens is this gets pulled up, so it comes at this position and then it is released. Once you release it, then it'll go back, and with inertia it'll go further down, so it'll go further down, correct? So it is going to bounce between two limits. Let me show those limits with the help of this line. Okay, fine. Now what we will do here is we will see with time how the position changes. So starting from the maximum, so let us start from here. With time it is going to come like this, go like this, something like this. Do you see that? So with time it is bouncing at the same place, but as time passes we are plotting those points stretched kind of, correct? So we are kind of plotting it like this, right? Let me just draw a few waves here and then we will try to understand them. So what has happened here is that this is your axis, and from the axis we pulled the spring and then released it. Then the spring bounces up and down according to the model d of t equals to 0.5 cos of 120t, where time in degrees, where d of t is displacement in centimeters. So this is displacement and displacement in centimeters from the rest position, that means from here, and t is time in seconds, right? So our axis really is right in the center. So I'm thinking of one color. Let's take this one now. So let's say that is the axis t, okay, and which is in seconds, correct? So that is the kind of situation where this cosine wave is represented by d of t equals to 0.5 cos of 120t, and everything is in degrees. That is the question. Okay, now the question is, what is the relationship between the amplitude of the function and the displacement from the rest position? Now displacement is given by this function. Now what is the amplitude? Amplitude is the maximum distance which it can go to. Now here we know amplitude is constant, and that is equals to 0.5, and the units are in centimeters, correct? So that is the unit, centimeters. So that maximum is 0.5. Do you get it? If we are considering this to be 0, then this is minus 0.5. However, all throughout, we have to say that the amplitude for the function is constant, which is just 0.5, right? Now, let's read it once again. It says, what is the relationship between amplitude of the function and the displacement from rest position? So this is what we have to explain. From rest position, how is the displacement changing with respect to amplitude, correct? That is what we need to explain. Now, one more thing which we need to find is, when we write d of t equals to 0.5 cos of 120 degrees, t degrees, then how much is the time from the starting of the wave for one full wave? This time period t can be found from 120 by dividing 360 degrees by 120 degrees, correct? It is the number of waves in 360. So when we divide, we'll get a number which is 3 seconds. Do you see that? 3 seconds. So this time here is, let me write here, 3 seconds. So every 3 seconds, this is 6, this is 9, like this. You see where this is 0 for us. So one cycle is completed in 3 seconds. Now we are in a good position to explain the relationship between amplitude of the function and the displacement from rest position. So let us try to explain it. Okay. Now initially what happens, that the displacement is maximum. It is same as the amplitude. So initially, displacement, let's say d of t, is equal to the amplitude a, which is 0.5. Do you see that? Then it decreases for 1.5 seconds, half the time. Do you see that 1.5? It decreases, right? So that means, so from the mean position, and this is 0.25, we are saying what is the relationship between amplitude of the function and the displacement from rest position. So displacement from the rest position decreases in the first quarter of a second. Then it goes to the other side, right? Becomes more negative. Displacement is I should say a vector quantity, means positive is and negative is treated different, right? So it is higher. Magnitude wise, maybe we could say decreasing, but here we will say on the negative side, correct? So in absolute terms, you can say that the displacement decreases for the first quarter of the second, then it increases, absolute terms, right? When it becomes equivalent to almost negative value, it is on the other extreme, and then bounces back, means displacement is 0 after quarter of a cycle. Do you see that? So displacement starts with maximum, which is equal to amplitude, and after, when t equals to 0.25, displacement is 0. Do you see that? When t equals to 1. I did wrong, 1.25. So 3/2 is this, 0.75 I should have written, sorry for that. Okay, so when t equals to 1.25, then displacement is equals to negative 0.5, right? Displacement is a vector quantity, it has direction, and then it increases positively, comes closer, right? So when it is 2.25, t equals to 2.25, then again displacement is 0, and at t equals to 3, displacement is same as the amplitude, which is 0.5, and then this cycle repeats. Do you understand? Then this cycle, this is one cycle, so this cycle repeats after 3 seconds, correct? That's why we are saying this is a periodic wave where the whole cycle repeats after 3 seconds. I hope you got the idea and you can explain it better. Okay, The whole idea here is that to start with, displacement is same as the amplitude. Amplitude is always same, but the displacement decreases with time. And then it becomes 0, then negative, and then 0 and positive, same as the amplitude. And overall it takes about 3 seconds for all this cycle to get completed, and then it repeats. So that is how you got to explain this. I hope that's clear. Thank you and all the best.